How do I graph y equals x squared minus 4? Well, it's already solved for y, so I could just type it into the calculator. Does anybody know what this x squared minus 4, what it's going to look like when I graph it? You've been through algebra 2, so a quadratic equation will always give you what shape? A parabola, yeah. Yeah, it's going to be a parabola, and it's been shifted down 4 units. So again, go to the table and just pick nice points. Bring it here. What kind of error is it telling you? Okay, so we have an error, and it says window range. What does window range mean? Does anybody know? Something with the window is messed up. So the window button is right here, and it said range. We'll look at the X min, X max, Y min, Y max. What's the issue? You have 9,000 and 9,000. You can't graph on a domain if you only have one point that's 9,000. So there's a couple of ways you can fix it. You can go in here and just type in another number, or you can do zoom and go down to 6 for the standard window and just do zoom 6, and now it's all fixed. Typically, your calculators will tell you what, and this is why you need to use a straight edge, because I can't draw straight lines. 0, -4, -2, 0, 2, 0. While I typically tell you don't use your calculator, it's faster. On this lesson, I think it is going to be faster if you use your calculator. Okay, so use it. There are ways where you can do different things, but if you can type it in, get all those points, graph them, life will be good. And I've got one more, and then we'll talk about some symmetry. Does anybody know what y equals 1 over x is going to look like? Have you seen something like that before? Nope. All right, so out of your wheelhouse. This is called a rational function. And your calculator appears that it is stopping here and here, here and here. And that's not true. On your graphs, you are actually going to have to show me. See how they get tiny, 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 tiny? And they get larger, 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 larger. At 1, I'm at 1. At -1, I'm at -1. But then it gets closer, closer, closer. What number can I not divide by?
0.
So 0 is not in my domain. So I'm not going to cross this vertical asymptote. Okay, I'm going to get closer, 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 and I'm going to get closer, closer, closer. There's also a horizontal asymptote on this one. And you only have 2 points that you have to label. Now, symmetry. What is symmetry?
What's on one side is exact same as the other.
Yeah, there's a mirror image. What's on one side is on the other. Looking at the first graph, what kind of symmetry do we have here? What is?
Across the x-axis.
Yes, this is across the x-axis. So this is symmetry with respect to the x-axis, or x-axis symmetry. On the values, when you're looking at those points, which values change, the x's or the y's? The y values. 1, -1. Those are different. So if you're having to do it by hand to determine whether it has symmetry with respect to the x-axis, you're going to see if your y values became the opposite, okay? On this parabola, what kind of symmetry does it have? Yeah, it's y-axis, or symmetry with respect to the y-axis. And which values change, the x's or the y's? The x's. So when you put in the opposite x, you have to get the same y out. Okay, so you put in your x, you get the opposite y, it has symmetry with respect to the x. If you put in your opposite of x and you get the same value, then it's y symmetry. What do you think this one is, this rational function? What kind of symmetry do you have? It is a reflection, or it's a flip, but what is it about? Where is my symmetry? The origin, yeah. Good job. The origin. This one has symmetry with respect to the origin. What changed on your points? Yeah, both the x's and the y's. Both the x and the y's changed to the opposite. All right, let's see. Determine whether or not determine a point that is symmetric with the x-axis, y-axis, and the origin. All right, so your point is a -2, -4. If that point is going to be reflected about the x-axis, what is my new point? What changed if it has symmetry with respect to the x-axis? -2, -4 is down here. So what is my new point? If it's reflected, yeah, -2, +4 is the new point with respect to the x. Now, same point. Now we're going to do symmetry with respect to the y-axis. What changes from -2, -4 if we're on the y? And we're going to flip it. It's going to be a +2, -4. And now for the origin, both of them change to the opposite. Are you okay with that one? Okay. Now, let's look at how this symmetry business is going to affect if we have and yes, you could always solve for y and graph it, but that is going to take quite a bit of time. So the fastest way is to replace your values, okay? So we're going to determine what kind of symmetry is it going to have. Does it have symmetry with respect to the x-axis, the y-axis, or the origin? So if I'm testing for the x-axis symmetry, what changes? The y values. So if I change this y to a -y, do I get the same graph out or the same equation? No. What's changed? Just the sign in front. So it's not exactly the same. It's not exactly the opposite either, correct? So what changed? Does this have symmetry with respect to the x-axis? What changes if you have symmetry with respect to the x? The y value, the output, has to be the exact opposite. Is this the exact opposite of the one that we started with? No. The only thing that changed was that middle sign. All of the signs did not change. So this does not have symmetry with respect to the x-axis. We're going to do a test for symmetry with respect to the y-axis. What changed if you have symmetry with respect to the y-axis? The x's. So I'm going to take my x and I'm going to replace it with a negative x in the original equation. And I'm going to simplify. Do I get the exact same equation out? Is this exactly like I started with? Yes. So this has symmetry with respect to the y-axis. To test for symmetry with respect to the x-axis, you replace the y with a negative y. It has to be exactly what you started with for it to have symmetry. To test for the y-axis, you replace the x with the negative x. To test for the origin, you replace both the x and the negative x and see if you get it out. So let's try another equation because I think this is faster. If I do problem 8, x equals negative y squared plus 5. We're going to test for x first. What do I replace? The y with what? The negative y. So what's a negative y squared? Positive y squared. Is this exactly what I started with? Yes. So x equals a negative y squared plus 5 has symmetry with respect to the x-axis. I'm going to test for the y-axis. What do I replace if I am testing for y symmetry? The x is the negative x. I can't simplify it any further than that. Is this equation exactly like I started with? No. So this does not have symmetry with respect to the y-axis. If I'm going to test for origin, negative x equals a negative y squared plus 5. I'm going to replace both the x's and the y's with a negative x, negative y. Is that exactly the same or opposite of what I started with? No. So it does not have symmetry with respect to the origin. So no y, no origin. Do you need to see another example of those? You're going to have to tell me if you have symmetry with respect to the x-axis, the y-axis, or the origin.
Why doesn't the negative y times by the negative make a positive y?
That is an excellent question. Why is this negative times this negative not positive? Who can answer that wonderful question? PEMDAS, orders of operation. You have to do parentheses and exponents before you multiply. So you're dealing with the exponent first, which is that negative times that negative is a positive. But then that positive times that negative makes that one a negative.
If it works for the x-axis,